kind of the random initialization with some of the mates instead of taking only the zero initialization. Random means we are going to be get any number maybe. So if suppose I ran this cell, suppose you have this cell, right? So I ran this cell np dot random. So at the time I may get around 2, maybe randomly I'm taking some value. So wi is equal to 2, wi is equal to 2, like that. So if suppose I ran again, I will get 4, maybe I don't know. So if I ran again, I will get 9. So randomly I'm initializing some of the weights with corresponding to the different nodes. So this how does this going to be helpful? Let's go and check out. You can see here he already written and he also implemented these kind of the things in the nodes. You can also play around with this code, play around with this kind of the nodes, so that you will get some idea how does it going to be helpful, the diagrams. So if you take this, maybe you can try to understand. It's somehow helpful when compared to the zero initialization what we just now seen. So you can see the red and the blue are the two different classes we had here. Somehow you can see somehow it's going to be separated when compared to this. Maybe I drawn like this, maybe, or maybe I can also draw kind of the non-linear transformation. Maybe I can draw like this. Somehow this is a misclassification points, obviously, but you eventually just separating with the red and also the blue points, right? Somehow the misclassification point for the red and also the misclassification point for the blue in this area. So you have just somehow decreases with some non-linear transformation. This is at least fine when compared to that. This not satisfied with the 100% results, but it may be satisfied with the 70% of the results when compared to that. So this is somewhat increases with the random initialization, but more prefer we cannot prefer zero initialization and also the random initialization. We cannot prefer these two, most probably. And something called as most famous also E initialization. So it's name itself with the E initialization because of we have some formula kind of the thing. You can say whenever we require to analyze any kind of the data, it needs some kind of the activity, or it needs some kind of the addition weights according to whatever the weight initializations we had. So this going to be helpful, something called as a vanishing grade problem also. Vanishing grade problem. So when we learn about some of the activation functions, I will tell you what is the vanish gradient problem and how does that going to be occurred. But as of now, you can say this vanish gradient problem occur because of the lots number of the zeros. Lots number of the zeros, or you can say weights, more weights are zeros, more weights are zeros. So that's how we have to avoid somehow vanish gradient problems. We can also discuss more in-depth concepts of the vanishing gradient problem in the activation function chapters. So yeah, it will resolve the vanishing gradient problem in terms of the he initialization when you apply it to the neural networks. So this is just a random initialization with respect to the this formula, 2 by sine of this formula. So you can see here it's somehow going to be represented what we just learned, and it also makes some sense to understand. So this is how somehow it's going to be classified between the blue and also the red region. So maybe he initialization is going to be works well. It's also not 100%. You can also say some of the blue points may be showcased here, and some of the you can say some of the red points also showcased in the blue range. But as per we discussed with the random initialization and also the zero initialization, may be separated with somehow 98% like that, maybe 98 to 97 or 99. So we also other initialization with the Xavier. So this Xavier somewhat extension with the he initialization. This is somewhat formula to showcase, but we just applying the multiple times. That's it. So this is also very interesting ideas. I can say this is not a you can say this is not a 1 day or 2 day implementations. This is came from maybe the 15 or 30 years research kind of the thing to how to initialize some of the weights according to the neural networks what we had. So these are all very old kind of theoretical deep learning concepts, but it's still it popular nowadays. Still in popular nowadays. We are just retrieving this because of TensorFlow and Keras. That's it. We're not doing any kind of the mathematical work, or we're not doing any kind of the theoretical nature whenever you encounter the IPython notebook. Just we are retrieving this information in terms of a library. So let's go and understand what exactly the disadvantage of the RNN and why we are doing as a LSTM mechanisms also. So yesterday we have seen RNN, and I also explained some disadvantage with respect to the RNN and some advantages also. So what will happen if you eventually do only the RNN in the deep learning concepts like recurrent neural networks while learning with some of the hidden layers? So if you have a long sequence, so I have a long sequence or long kind of the sentences, it may not be preserved. It may not be preserved. So that is a major concern here. May not be preserved long kind of the sequence. So in this case, we have LSTM cell, long short-term memory, we can also call it as. So it will preserve long kind of the sequence with three different gates. So one gate is, you can see in this cell, this is the LSTM cell. This completely is the LSTM cell. We have so many cells. Just now we discussed, right? So like this, one cell, second cell, third cell. We have so many different cell. We can represented each cell as like this. So if you go and understood how does every cell is going to be do some of the different gates, something called as input gate, and second gate is called as forgot gate and output gate, and also candidate gate, I can say memory gate or candidate gate we're going to be represented, but it is intermediate gate, not in between the virginal gates, or also you can say header dates. These are the header dates, these are the intermediate gate, you can say. So if you go and understood in depth of knowledge, this is somewhat not that much of easy to learn mechanisms. I have another cell to learn easy method, so I will take this cell and I will also explain to you. So if it take this, whatever we learn, all the different gates we are going to be showcased in the LSTM cell. So you can pass and understood what are the different terminologies we are using in the LSTM cell and how does it going to be works out. So if you take any kind of the NLP concept with respect to the sentence context, sentence. So I'm passing some sentence called this is a statement. So these kind of the words or these kind of the sentence, it's going to be preserved as an input to the whatever the cells you are going to be represented. So yeah, if you just consider for each and every I can say this is called as one state or one kind of the notation in terms of whatever the cell represented we had. So what will happen eventually, so this is the input we are going to be get from whatever the words you had. So you're going to be get the input corresponding to the cell, and you will also get some hidden states, or you can say some hidden information from according to the previous cells. So it's going to be works out with the same RNN what we learned. So we have RNN, right? Yesterday we have seen with respect to the time access. So this is one cell for the RNN, this is an Excel for the RNN, and this is an Excel for the RNN. So we just represented using the time access, you can say. Whatever the information you are going to be present or we are going to be preserved with respect to the cell, it's also produce some output with corresponding to it's going to produce the results with respect to the next layer or next cell. So like that, we are going to be represented. You can see T minus one. So if you have a three different cells, you will quickly understood. So if you have a three different cell, so I will call this is a current and this is a past. I will represent by using the T minus one, and for the future I will represent T plus one. So that what will happen eventually in this layer or in this cell, this is the one cell, current cell, this is the tree. So you can see whatever the memory information you're going to be get from the previous cell or previous kind of the words. If suppose this is a T cell, I will going to be get this as a previous information to my current timestamp or current cell. So I will get this information from this memory along with some hidden states, whatever the hidden states what we had, and it's going to be concatenated together with your input, whatever the input we had. That is right. That is a is going to be concatenated with them. So if we go and understood